Hi guys, it's Mrs. Manley here with your last video on our linear functions EQ. So we're going to finish up today. We don't have any LHS mastery this week. We gave you guys a break this week because the students in school are taking county benchmarks this week. You guys will take your county benchmarks online, I believe, next week. So for the time being, no LHS mastery homework this week, but you will have a review activity that you will need to do after your video. So these last set of problems that we're going to look at today are T&Ready practice problems, meaning that they're modeled after some of the T&Ready practice problems we've seen on linear functions. So here's our first one. They're all going to be in word problem form. So the town of Willowick takes a census of its population every 5 years. The data are displayed in the table. What is the average yearly change in population in Willowick from 1997 to 2017? So as soon as you see average yearly change there, you should think about the fact that we've been doing slope and rate of change. So this should tell you that this is a rate of change problem. So to find rate of change, we're going to do change in y over change in x, right? So, you can just look to see how your y's are changing, how your x's are changing, or you can do y2 minus y1 over x2 minus x1. So if we do that, we've got x1, x2, y1, y2. So we're going to have y2. Let me switch to regular pen. So y2 is 26,530 minus y1, 25,480 over x2 minus x1. So then, I'm just going to use my phone calculator here. So you're going to plug in 26,530 minus 25,480. It's going to give us 1,080 over 2002 minus 1987 is 5 years. And then we need to divide. So 1,080 divided by 5. Something didn't come out right. Sorry, let me see if I put something wrong. 26530 minus 25480 should be 1,050. And then divided by 5 is going to give us 210. So our average yearly change is 210. Now, here's what that means. 210 would be the same as 210 over 1. 210 is my y, so that's the population, and x is the year. So basically, the population is changing by 210 people every 1 year. All right, let's take a look at the next problem. So on this one, we have one end of a metal spring is attached to a ceiling. The other end of the spring hangs down. The table displays the length of the spring when different masses are tied to the end of the spring that hangs down. So we have our table here, and this says how much longer does the spring become with each extra kilogram of mass that is tied to it. Again, it doesn't directly say to find the rate of change or slope, but we're giving you a table. And with linear functions, we've been doing just a few things with tables. Finding the initial value, finding the rate of change, writing the equation. Okay, so for this one, we're probably going to find the rate of change again. So same thing, x1, x2, y1, y2, 434.3 minus 434 over 3 minus 0. We know 3 minus 0 is 3. And then 434.3 minus 434.0 is going to give me 0.3. And then we got 0.3 divided by 3 is going to give us 0.1, which would match up to answer choice C, 0.1 or 1/10. So again, that's the same as 0.1 over 1. So that's telling me that the length of the spring changes by 0.1 centimeters for every 1 kilogram of mass that's tied to it. All right, next question. The expression 780 plus 25t represents the total number of students who graduated from Schuyler School T years after 2008. Which value best completes each sentence? Part A, the number of students who graduated from, I should say, Schuyler's school each year is blank. And part B, the total number of students who graduated from Schuyler's school through 2008 is blank. All this is asking you to do is look at the parts of your equation or expression, okay? So the 780 that's by itself, that would be my initial value. So that's whatever I started with. My 25 is my rate of change. Okay, so T stands for years, tells me that right here. So this is 25 per year. So this is the changing students. 25 students per year. So it says the number of students who graduate from Schuyler School each year is, well, that's going to be 25 because 25T is 25 per year. Then that only leaves 780. The total number of students who graduated through 2008 is 780. Okay, so 780 is the amount we started with prior to 2008, and then 25 per year. All right, another question very similar. Again, we're looking at our expression. The expression 1020 plus 200t represents the total number of cars. Honda sells T years. So if I know T is years, this has to be cars. Cars per year. 200 cars per year after 2000. So this means this would be prior to 2000. Which value best completes each sentence? The number of cars sold each year is 200. Total number of cars they sold through 2000 was 1020. So again, it's just breaking up the rate of change from the initial value. Excuse me. From years 2000 to 2009, the number of coffee shops in Rutherford County has decreased by 200 shops per year. In 2002, there were 1,600 coffee shops. So I'm going to start by highlighting some important information before I do anything else. So from 2000 to 2009, coffee shops were decreasing by 200 shops per year. 2002, there were 1,600 shops. Which equation gives the relation between the number of coffee shops, C, and years T, where T equals 0, represents the year 2000? All right, so a couple things here. First of all, T equals 0 would be U. Because remember, in a table, my initial value is where x is equal to 0, so 0, comma, whatever is your initial value or y-intercept. So we're going to use the year 2000 as being T equals 0. All right, and then it says that we need to write an equation here. So equations are going to be in the form y equals mx plus b, which in this case they're not using x and b and y, they're using t and c, which is fine. So we already know my initial value is the year 2000. So we need to know how many coffee shops there were in the year 2000. Most of you are going to say, oh, it's 1,600. But that's how many there were in 2002. So I need to go back 2 more years. So we need to think about how it's changing. So it's decreasing by 200 shops per year. So just to make this a little easier to understand, we could draw a table here. All right, so we need to get back to the year 2000. I'm going to draw out to 2003 here. All right, we'll say this is year, this is coffee shops. Right. So we know in 2002 there were 1,600, and it's telling me I'm decreasing by 200 each year. So that means I'm going to go minus 200 in 2003. So to go backwards to get to the year 2000, I'm going to have to do the opposite, which would be add. So it would go 1,800, 2,000. Okay. So then my initial value, years, is right here. Okay, 2,000. So first of all, I need one that has an initial value of 2,000. So I can get rid of C, and I can get rid of D. Now all I need is my rate of change. My rate of change is 200, and specifically it's decreasing 200, meaning negative 200. So that gets rid of A. All right, let me move this back. There. That gets rid of A and leaves us with B. In 2000, we had 2,000 coffee shops, and we lost 200 every year after. All right, you try the next one. The next one is similar to the one we just did. So go ahead and pause your screen here, and then unpause to see how you did. All right, from the years 2000 to 2018, so these are the years we're dealing with, the number of students who attended LHS has increased by 50 students per year. 2010, there were 1,400 students. Which equation gives the relation between the number of students S and years T, where T equals 0, is the year 2012. So again, you could do a table here. So T equals 0 is 2012. So we'll go through 2015. So it told us in 2010 there were 1,400 students. Did I go the wrong direction? I did. Let me erase this and switch to pen. Okay, let's try that again. All right, so we know how many students there were in 2010. There were 1,400. So this is year, students. Okay, so we're increasing by 50 students per year. So 2011, 2012, 2013. The number I'm looking for is 2012, because that's what wants to be our initial value year. But we started increasing by 50 students per year starting in 2010. So then this would be 1,450, and then this would be 1,500, 1,550, and so on. All right, so for my initial value, they told us that was the year 2012, and that's 1,500. So that means I can get rid of C and D. And then is it plus 50T or minus 50T? Well, if we go back, it was increasing by 50T, or by 50 students per year, so it's A. All right, next problem. A shipping company charges a cost per pound plus a fixed fee to ship a package. The total cost, f of x in dollars, of shipping x pounds is modeled by the function shown. F of x equals 599x plus 675. So when we break down an equation, when you see a number with a variable, that's telling me $5.99 per something. In this case, per pound. Okay, so that means the $5.99 has to be the cost per pound. $5.99, and then X is the number of pounds. That tells me my fixed fee then has to be the $6.75. So part A, which part of the function represents the fixed fee? The fixed fee is the $6.75. Part B, what does the slope represent? Remember that my slope is not mx. Okay, when we look at slope-intercept form, here's what we have. M is my slope. B is my y-intercept or initial value. X and y are coordinates. Okay, that's an X and a Y from your problem. In this case, in this word problem, Y is going to be the total money I spend, and X is going to be the pounds. So it says, what does the slope represent? So we have number of pounds, cost per pound, or total cost. So that slope is the cost per pound. So B. Just seeing where we are. All right. So we're right here. Grace and her brother need $600 to go to band camp. So $600 to go to band camp. Their parents have agreed to help them earn money by paying them $15 each time they mow and $10 for each hour they babysit their younger brother. They will have to do a combination of both chores to earn money. Select an equation that represents the number of lawns they can mow M and the hours they can babysit B to earn $600. So we would need to ask ourselves, what number goes with mowing? Okay, so if I look back up here, $15 every time they mow. So I need a 15M, 15 for mowing. That takes A out and B out, right? And then I need $10 for babysitting. And then remember, it's a combination of both. So they have to mow plus they have to babysit. So that tells me that my only logical option is C. $15 for every time they mow plus $10 for every time they babysit will eventually get them $600. And I believe that's where we're going to end. I do have up an assignment on the next screen, but we're not going to do that assignment. Instead, you guys are going to do a review activity. So I'm getting ready to make a review activity that I'm going to put up for you that's going to get you reviewed for the quiz. And you will take your quiz on Wednesday and Thursday. Okay, so even students will take your quiz on Wednesday. Odd students will take your quiz on, Thursday. Even on Wednesday, odd on Thursday, and this is an odd week again. This is an odd week again, so this week goes even, odd, odd. Okay, have a great day. Email me if you have any questions. Remember that you can redo any of your LHS Masteries once I send you your score and your feedback. You can also do retakes on all quizzes and tests within the time period after I put up the retake. Okay, have a great day.